Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to learn about lines and linear functions. The first thing that I'd like to start off with is saying that this is a topic that you have covered almost every single year of middle school and as well in ninth grade. So when we go through this, we're not going to go through it like one piece at a time as we generally do, right? If you feel like you're not very strong with lines, then the one thing I will recommend to you is there's videos that I've linked underneath the website for chapter 7, or sorry, lesson 7, where it says videos, right? And by all means, please watch those videos because it's important that you understand lines, and then you can watch this video, right? But let's get started. So we're going to be working with three formats of a line: the point-slope form, where I'm pointing now, the slope-intercept, the standard, and then we're going to be talking about the equation of a vertical line, a horizontal line, and eventually in the part 2 of this lesson we'll talk about something called the fixed variable cost equation, and of course we're going to talk about slope in this lesson. We're going to talk about how parallel lines have the same slopes and perpendicular lines have negative reciprocal slopes. Now as you're looking at this and you're thinking to yourself, wait a minute, I know a lot of these, then I would actually recommend that you pause the lecture and try to see if you can do those questions instead, right? Do the homework. But if the homework you get caught on it, then you're welcome to come back to this and to watch these videos, right? So let me give you some guidance. Sometimes you can have a graph and the graph asks you to find the slope of the line and to interpret what the slope means. And so the slope of the line, I am quite confident every single person in the classroom knows. So we're not going to go much into that. All right, we know it's rise over run or y2 minus y1, however it is that you want to call it. But for number 14, what we can say is the slope of this line is going to be 2 minus 1 divided by 2 minus negative 1, which is 1 over 3. All right. Now what does that mean? Is it really important for you to interpret it? So it means for every 3 units that we travel in the horizontal direction, for every 3 units we travel in the horizontal direction, we also travel 1 unit in the vertical direction. And so that is the interpretation of it. Simply to say, oh, it's just a rise over run, that's not sufficient. Okay. Now, the next exercise, because you do have homeworks from all this, it simply asks you to plot these points yourself and then tell the slope of the line and then graph the line, right? So as long as you have 2 points, you can always graph a line, right? So in all of these questions, they give you 2 points and they know that you can graph a line with them. And after you have graphed a line, or even before you do it, you are welcome to find the slope of that line. Now, the ones that I want to just slightly spend a bit of time on are number 26 and number 30, right? Because they are a little bit different, and 28, right? So number 26, really quickly, it says that you've got a point on a line that's 1, 3, right? And the slope of this line is negative 2 over 5. So it says graph this line containing the point and having the slope m. So you should be able to very quickly make a sketch, right? So as I am talking to you, I am also making this sketch. That's just how long it should take, all right? So there you go. I made a really quick sketch. We'll make the point first. So 1, 3. So 1, 2, and 3. And there's my 1, 3. All right? I know everybody in the class knows how to do this, so I'm just rushing through it. Then we can take that negative and call that -2, so that's our rise. And then we can take that +5 and call it our run. So we're going to go -2 down, okay? And then we're going to run +5. So if we're at 1, I want you to think how much is 5 units from 1, and the answer that should come back to you is 2, 3, 4, 5, and 6. So you should be going in that particular direction as far as the slope is concerned. So your rise was a -2 and your run is a +5. Then again, everybody knows that, okay? And then you just go ahead and you graph the line that goes through those 2 points right there, okay? And it's not a line segment, it's an actual line, so you put arrows on both ends, and there's that. Number 28, it says, now can you graph a line that goes through, Bismillah, 2, -4, and it has a slope of 0. So I want you to think, what does a line with the slope of 0 really look like? Because initially you might think to yourself, wait a minute, where's the rise and where's the run in that, right? So first off, let's just put a little graph over here. All right, it's not going to take too long to do this question. So you've got a point which is 2, -4. All right, so I don't mind really quickly saying, okay, here's 2, here's -4. All right, just a very crude drawing. That's my 2, -4. And now I'm looking for a slope of 0. What that means is the slope is a 0 over 1, if you want to call it that. Meaning your rise is a 0 and your run is a 1, if you want to think of it that way, okay? But generally what they say is you keep running, okay? It's infinity. You continue to run left and you continue to run right, sort of a thing, okay? So go to that point once again, and from that point you want to just go ahead and make a line with a 0 slope. Oops, sorry, that was a line fail. So make a line with a 0 slope like this, and from here on out, just remember that's what a line with a 0 slope looks like. It's completely flat. It's like the ground that you're sitting on. Hopefully it's flat. All right. Number 30. Number 30 is very similar. This time it says that the point is -2, 0, and the slope is undefined. So you don't say it's equal to undefined, you say it is undefined, right? So let's figure this part out. What does it mean when you have a point at -2, 0, yet your slope is undefined? Because clearly that doesn't really have a rise over run, at least it seems like in the beginning, right? So here is my -2, 0, right? And I'm going to go ahead and make a point right at -2, 0. I want you to think of it this way. I told you slope is still rise over run. But what is it in a fraction that you cannot have in the denominator? And the answer is 0. You can't have a 0 in the denominator. You can have whatever number you want. You could put infinity there if you want. You could put any number that you want. But in the denominator, you have a 0. So in other words, what we're trying to say here is you can continue to rise from that point. You can go up, you can go down. But what you cannot do from that point is you can't run from that point. So you can't go left or right. And therefore, a line that looks like this right here is always going to be a vertical line. So whenever you hear that the slope is undefined, you're automatically going to go ahead and make a vertical line. So that is objective number 1. That really has never been an issue for any student in the past, so I just kind of browsed through that really quickly. Now we're going to move forward and we're going to talk about making equations of lines. So that is objective number 2. This might be something that you might want to slow down on and make sure that you know how to do very well, because we do a lot of these in pre-calculus as well. All right, so what we're going to do is we're going to try number 40, we're going to try number 42, and we're going to try number 44. All right, so let's talk about number 40 here. The slope of this line will be 2 minus 1, which is your rise, and then your run is 2 minus -1, and so you'll have 1 over 3 as the slope of this line. Okay. Now we're going to pick both points, all right, and we'll start with -1, 1. And the way that you work with this, and the most common way to work with it, I know different people have different techniques, is to put this into point slope form. Okay. Yes, you could have chosen the other point as well. We just simply decided to choose the point that you're looking at. All right. So you'll have y minus 1 is equal to 1/3 x plus 1, like that. And then y minus 1 is equal to 1/3 times x plus 1/3 times 1. So in other words, you distribute that right there. And then you bring the minus 1 over, so it becomes y is equal to 1/3 x plus 1/3 added to 1. And now the common denominator is a 3. So once you get that 3 working for you, Bismillah, you'll have y is equal to 1/3 x plus 1 plus 3, which is 4, so 4/3, okay? And please be convinced of this. If you take a look at the graph itself, you'll notice that the y-intercept is truly a 4/3, okay? It's one whole unit, and then it's a third of the unit right there, right? So it makes sense that that's 4/3 right there, or basically 1.33, and it's got a relatively flat slope, so the slope is a 1/3. Now, if you decided to use the other point, we've had conversations about this before, you're welcome to do so, and when you do that, you should still arrive at the same exact conclusion as you have over here, and that's one of the reasons why we prefer the slope-intercept form as opposed to the point-slope form, because in the slope-intercept form, regardless of which point you use, everybody comes to the same exact answer. All right. Now let's go to number 42. In number 42, basically, it's the same exact thing. You need a point and you need a slope. All right. You can't start till you don't have both of them. Now the objective is to find the equation of this line. All right. We got to find the equation for this line L. That's what the instructions say. We don't need the equation of the other line. The equation of the other line, in fact, is already written there. All right. So here's the clue that they give you. The clue that you're given is L is parallel to y equals -x. And so we talked about this in the lesson earlier, is if you have a line that's parallel to another line, they're going to have the same what? They're going to have the same slope. So you just got to look at this equation and be like, well, if that's y equals -x, then the slope of this other line must be -1 because it's mx plus b. So that means because our line is parallel to the other line, our line must have the same slope. Now, what does our line, what point does it go through? It goes through 1, 2, and once again, you've got everything that you need to really quickly establish the equation of this line. So here I am plugging into the point slope form. This one doesn't have any fractions, so there's no reason to make any silly mistakes with it, I would imagine. So you end up with -x plus 3 as the equation of this line. And again, be convinced of it. Take a look at. There is a y-intercept of 3. And people who are experts with these types of things, they wouldn't even go through all this. They'll be like, well, it's got a y-intercept of 3, and I know it's going to have the same slope as the other one, so -x plus 3, right? But take your time with this. So that is your y-intercept, and it makes sense that it shows up in the equation. And then, of course, it's got the same exact slope as the other line. You'll even notice that they do actually visually look parallel, okay? All right, let's go to number 44. Unfortunately, the problem with this is, you learn this, you learn it again, and you keep forgetting it, okay? So now what we're telling you is these two lines are perpendicular to one another, okay? So the secret here is the following, all right? First off, the point that we're looking at is -1, 1. Notice how both of the lines are going through the same exact point. That's perfectly okay, all right? But the one that we're interested in finding the equation of is the red line over here. We're trying to find the equation of line L. So what you got to realize is basically all I got to do is I got to look at the equation of the other line. The equation of the other line is y equals -x. and the slope of the other line is -1. Now what you need to do is you have to say that the slope of my line, which is perpendicular to it, is the negative reciprocal. Right? See how I said that? You always put a negative, and then you turn their slope over. So when you turn their slope over, you'll actually find that you have two negatives, which will make a positive. So in other words, the slope of your line is going to be a +1. All right? And so having said that, with a point and a slope, and again, like I said, there's people who are experts with this and could say, hey, look, that right there looks like a y-intercept of 2, and I know that this line L has a slope of 1, so I can just say that this is going to be x plus 2, and I'm done with it. But if you miss that, right, if you miss that, that's perfectly fine, right? At some point you will become very comfortable with it. We would hope that at this point you would have gotten there, but it's okay, all right? So you'll get there, inshallah. So this right here becomes a plus, so you end up with y is equal to 1x plus 1, and then when you have the -1 come over, it becomes y is equal to x plus 2, and just as I had said, that is what we expected. You just want to verify that that is the y-intercept that we talked about, and it does have a slope of 1 right there. Okay? All right, so we got a long ways to go in this lesson, and I think the most important part of this lesson is, actually no, I said a long ways, not necessarily. This is actually the last slide here. It's just I need to do a handful of examples here to get the point across, generally speaking. So in these questions, basically you're going to be given different kinds of descriptions, and every single time you have to be able to use that description to set up an equation of a line, all right? So the easiest one usually for students is something like number 48, right? That you have a point, you've been given a slope, so really quickly for number 48, the quickest way to do it is to say, well, if you're giving me a point and you're giving me a slope, right? I have a m value of 1/2. Just look at all the examples that I did previously to this, right? You can put this into point slope form. Y minus 1 is equal to 1/2 times x minus 3. And then you can take your time to actually simplify that and to see where you would get to it. Though, for now, because I have to get through a lot of this lesson and I want to spend some more time with the harder kinds of questions, I will just leave it to that. But your job is to turn this into slope-intercept form. Okay, so slope-intercept form, once again, what does that mean? That means you multiply the half in, and then you bring this -1 over, and all of that good stuff as I demonstrated to you a handful of times above over here, all right? So once, twice, and then thrice. So that's basically what we're expecting you to be able to do on the fly really quickly when you get to pre-calculus, right? All right, so that was number 48. Now let's take a look at number 50. Number 50, what's missing there? You want to ask yourself, what don't I have? This time you only have 2 points, and what you're actually missing is a slope, right? So we dealt with this problem all the way a moment ago in number 40, where you had 2 points, but you didn't have a slope, and you want to ask yourself, what did we do? What we did is we found the slope, and then we were back in business. Okay, so it's not something that's different over here. Now that we have a point and another point, so you have 2 points, given 2 points, you can always just calculate a slope, right? So what is the slope of this line going to be? It's going to be 5 minus 4 divided by 2 minus -3. So that's going to give you a 1/5. So that is the slope of the line, right? And again, you just pick any one of the points that you want. So I'll pick the second point, and I'll go ahead and I'll put this into point slope form. I will remind you again that you need to be very fluent with turning the point slope form, which this is, into the slope-intercept form, right? So I've easily said that 5 or 6 times in the last 20 minutes, all right? Number 52, all right? This one's interesting. It is probably the easiest one, I would say, on this whole set. Now you've been given a slope, all right, you have a slope of -2, and you have a y-intercept. You have a y-intercept of -2, all right? For those of you who are familiar with the mx plus b format, what many people call, is really the slope-intercept format, okay? So the y-intercept belongs right there. That b was called the y-intercept. And the slope belongs right over here. So guess what? Without much effort, we are already done with this question. You just need to know how to work with these problems. So there you go. That is now in slope-intercept form. Sometimes students ask, wait, what if I am so accustomed to point-slope form that I want to put it into point-slope form? You might be making things difficult for yourself, but I don't mind reminding you that a y-intercept, really what it means is it's a point that's 0, -2. So now you have a point and a slope, and you could just go ahead and set up a point-slope form, right? So y minus -2 is equal to -2 times x minus 0. And then these two will make a y plus 2 is equal to, multiplying in is going to basically give you -2x, and that 0 doesn't really count and it doesn't really matter. So you end up with the same exact answer, y is equal to -2x. Bring this guy over, minus 2. There's that. Okay, so even if you decide to stick to point-slope form, you'll be perfectly fine as you go through any of these questions that you're looking at here. All right, let's take a look at number 54. Number 54, initially, you're looking at it going like, wait, what's an x-intercept? What's a y-intercept? So let me just help you understand this question with a picture. Okay, just usually if you're not getting, wait, what is this description talking about? Just draw yourself a picture. And that's what we actually began the lesson with pictures, and it really helps to understand. So what they're saying is this line has an x-intercept of -4. All right, so -4 is its x-intercept. That's what x-intercept means, is it touches the x-axis at -4. And it's got a y-intercept of +4. Okay, now I want you to think to yourself, do I have something based upon this? And you certainly do. You have 2 points based upon that. Okay, when they told you an x-intercept, they told you -4, 0. When they told you a y-intercept, they told you 0, 4. But if I had simply written these, you might have actually looked at it going like, I don't know how you got those answers. But there you go. You've got those 2 dots, right? You've got those 2 coordinates. You know there's a line that is going through these 2 coordinates, and you simply need to find the equation of that line. Once again, I don't need to repeat this whole process again. If you have 2 points, you can go ahead and find the slope, and then it goes back to point-slope form, right? So this is an excellent set that really forces you to know every kind of way that you could possibly encounter lines, right? Even then, I've seen even more creative things come around. Number 56 says, now you have a slope which is undefined. So go to the beginning of the lesson if you don't know what an undefined slope might look like. And it contains the point 3, 8. I'll draw this for you again, okay? Because it's, it's a little hard to convince people, but once it clicks for you, it simply does. So you know that this line is going through 3, 8, right? That's the point that it's going through. So let's suppose this is my 3, right? This is exaggerated and off scale, but that's not really a big deal right now. So there you go. There's my 3, 8, right? And then it's telling you that the line is going to have an undefined slope. So let's pause here and let's go all the way to the beginning of the lesson. And what did we talk about undefined slopes? In number 30, we said that when you have an undefined slope, it's essentially a vertical line, right? Because the run is 0, whereas the rise is infinite. You can go up and you can go down. So having said that, if you think about it, now we're trying to make an equation of a line. We're not just trying to identify things about it. So here, first off, here's your graph. Okay, here's your line. The equation of this line is actually going to be, even though it's a vertical line, this gets students all the time. Even though it's a vertical line, I get that, right? Its equation is going to be x is equal to 3. And the best way that I ever understood it is somebody said to me, look, x is always, right? X is always going to be equal to 3. No matter where you go, right, as far as the y's are concerned in this vertical line, x is always 3, so that is the equation of that line. All right. Number 58, if you think about it, it's really going just a line in a different direction. This time they're telling you that it's it's actually going in the same direction. So they're telling you it's a vertical line, right? Well, what do you understand right away about a vertical line? It's got a slope which is undefined, right? And they're telling you a point that it goes through, which is positive 4, comma, negative 5. And let's see if you can just manufacture the equation without trying to make a graph. You know that the equation is always going to have an x in it, and it's always going to be x is equal to the coordinate where it's going through in the x's. So therefore, the answer to this problem is x is equal to 4. Again, if it doesn't make sense, draw a picture, but x is always going to be 4 as long as this line is going to be vertical. All right? Now, this is usually where I tend to slow down a little bit. This is something that even my calculus students tend to struggle with, so don't feel bad. Number 60, it says that you have a line that is parallel to y equals negative 3x. Again, this is not your line. This is some other line, and your line is parallel to this line. So let's just pause here. If your line is parallel to y equals negative 3x, what is the equation of your line? Right? And the answer that you should get is any parallel line is going to have the same slope. So the slope of your line, this is your line, okay, and this is a different line. Y equals negative 3, this is a different line. Okay, so your line has a slope of negative 3. So now you've got something, you've got a slope. What else you need is a point, right? So look around in number 60. Do they provide you with a point? And they certainly do. They tell you that the point is negative 1, 2. Again, with those two things, you can make the equation of your line, which is negative 3x minus negative 1. Y minus 2 is equal to negative 3x, and then this right here is a plus, so that's going to make a minus 3. Bring the minus 2 over. Y is equal to negative 3x minus 1, and that is the equation of your line. You'll notice that your line has the same slope as the other line. What's different about your line from the other line is your line has an intercept of negative 1, whereas the other line has an intercept of what? It's got an intercept of 0, right? So it's going through the origin, all right? So we have a few more to go, inshallah, all right? If I'm going too fast for you, again, that might mean that possibly that you just kind of struggled always perhaps with understanding lines. So you do want to watch some of the more basic videos that I posted on the website for you to be able to understand lines. But again, like I said, it's very important that you understand them though. Okay. Number 62. All right. Number 62 says that this time your line is parallel to this line right here. X minus 2y is equal to negative 5. And your line is containing the point 0, 0. So you already have a point, right? So you've got a point to work with. You're not concerned about that. But what you're concerned about is where is my slope, right? So to figure out the slope, you have to make those connections, just like you did in number 60. Number 1, your line is parallel to this line over here, right? It's parallel to it. So usually here's what students say. They say, why don't we turn the equation of this line into mx plus b? Right? So y is equal to negative 1 over negative 2x minus 5 over negative 2, and therefore y is equal to positive 1/2 x plus 5 over 2. That's usually what students say. Then they say that, okay, now I know the equations, that this line's slope. This line's slope is a half. And so what that means is your line, because it's parallel to this line, must also have a slope of a half. So if you're looking at this going like, wait, why did they give us this other equation? They gave you the other equation so you could figure out the slope from it. That's the idea, right? So now you know now you know a slope for your line, and you know a point for your line, so you can put it into point slope form and get the job done. So if you want to go with point slope form, y minus 0 is equal to 1/2 x minus 0. And therefore you'll have y is equal to 1/2 x, and that is the equation of your line. Again, you'll notice that the slope of your line and the slope that's already previously highlighted up here are the same, and that makes sense because that's the very definition of parallel lines. All right. Number 64. All right. Whenever you're in doubt or you're stuck, I'll give you some good advice. Maybe you're just a visual learner, and that's not a bad thing. So just draw a picture for yourself. It might help. All right. So for number 64, it usually helps if you draw a picture, especially if you don't understand what it's talking about. So here's what we know. We know that our line is parallel to the line y equals 5. Okay, so you got to ask yourself, what does a line y equals 5 look like? If you've never learned this before, then I'll teach it to you. Just like a line that was x is equal to something, right, was a vertical line, right? The same way y is equal to something is a horizontal line, okay? And the reason why that confuses kids is because they're like, wait, I thought y was vertical and x was horizontal. Again, we're talking about a line and the equation of it, so it's kind of backwards in a sense, okay? So y is equal to 5 is the equation of this line. Not your line, but their line, okay? Your line is containing the point 4, 2. Now I want you to think to yourself, where is 4, 2? Let's suppose that is right here, 4, 2. Now, what's the relationship between your line and their line? This is what's important. You got to realize if it's parallel, then it's going to be running side by side with their line. And now let me ask you. You already know that the point on your line is 4, 2. You already know a point. It's 4, 2. Can you tell the slope? Because that's what it really comes down to. So if you drew the picture, you'll be like, wait, if this is a horizontal line and my line is parallel to the horizontal line, that means my line must have a slope of 0. So with these two things, you can quickly go ahead and write down y minus 2 is equal to 0 times x minus 4. And therefore, you'll have y minus 2 is equal to, if you multiply the 0 in, you actually just get a 0. So if you solve for y, you end up with y is equal to 2. In other words, the equation of your line is y is equal to 2. All right? I know for a fact that there's a number of students in the class going like, wait, why do you need to do it that way? I have a better way. Please, by all means, if there's a way that you've always been comfortable with, stick to it, and you'll be fine. But I need to make sure that everybody knows all the ways and is comfortable with them. All right, now we're going to try number 66. All right, number 66 says that your line is perpendicular to y equals 2x minus 3. All right, your line is perpendicular to it. And furthermore, that your line is going through the point 1, negative 2. So I think with all these examples so far, you're like, okay, I got the point, right? I need the slope. So here's how we're going to get the slope. First off, we don't know slope just yet, but we've been told that this y equals 2x minus 3, it's perpendicular to our line. So here's what you do. You say, well, if the slope of this line is 2, the slope of my line, which is perpendicular to it, must be the negative reciprocal. In other words, it must be a slope of negative 1/2. So that is the slope of my line. And with the point and with the slope, those two are the two things that you need. And you can really quickly, y minus negative 2 is equal to negative 1/2 x minus 1. These two will become y is equal to y plus 2. And this right over here, let's just leave it in its format where it stands, is your point slope form. I think you're all comfortable with turning it into slope intercept to some degree. Okay. All right. Number 68. Really the same question. Again, your line is perpendicular to x minus 2y is equal to negative 5. What have students done in the past? They've said, well, I can't tell what the slope of this line is just by staring at it. So what they do is they say, let me turn it into y equals mx plus b format, or what we know as slope-intercept format. So when I do that and I divide by negative 2 on all sides, I end up with y is equal to positive half x plus 5 over 2. But be careful, this is still the equation of the other line. Okay, this is still the equation of the other line, and you know that its slope is a half. So your slope, okay, your slope is going to be the negative reciprocal of this slope. And that's putting 1 divided by that. That surprises a lot of people. That's what reciprocal means. Doing 1 divided by that fraction gives you its reciprocal, and that's going to give you negative 2. So the slope of your line is a negative 2. They tell us that our line is going through 0, comma 4. So with a point that is 0, comma 4 and a slope which is negative 2, once again, you're in business and you can go ahead and just quickly jot down the equation of this line over here. All right. All right, let's come down to our last example here, which is number 70. If this was the first time, by the way, I was teaching this to you, this lesson could have easily been 2 hours long, but it's not the first time that you're learning it, and I don't want to bore you with all this information that you already know, so I try to keep this lesson very short, right? So here, your line is perpendicular to the line y is equal to 8, right? So if it helps, you know, whatever helps you learn, inshallah, I'm willing to do that. So y is equal to 8 is a line, all right? Y is equal to 8, right? So I don't know why I keep drawing crooked lines, but there you go. That's my y equals 8, all right? Y equals 8. And your line is perpendicular to this line, and it's going through 3, comma 4. So 3, comma 4 might be somewhere over here. Here's 3, comma 4. And your line, not only is it going through 3, comma 4, it is also perpendicular to that other line, right? So they make a 90-degree relationship. So again, what you want to really quickly do is be like, well, this line that they gave to me has a slope of 0 because it's a flat line, right? So my line must have an undefined slope because it's a vertical line, right? And don't freak out going like, wait, how am I supposed to put that into mx plus b and stuff like that? Don't worry about that, right? So let's talk about vertical lines, right? We've seen this a couple of times now. How do you write the equation of a vertical line? You simply take its x-coordinate, right? You simply take its x-coordinate, which is a 3 right now, and you write down that x will always be equal to 3, all right? So your line's equation is x is equal to 3. Their line's equation was y equals 8, and here is the one that you were looking for, all right? So thank you so much for listening. I've left in that lesson a nice little cheat sheet for you. I don't think we're going to be taking, sadly, any tests in class, but, you know, this is a really nice sheet to sort of look at when you're going through them. Just one little remark to make. Standard form is a form that, you know, it's rarely talked about, and I barely got a chance to give you an example of it, but I just want you to think, if somebody told you, look, don't turn this into mx plus b, yet still graph me a line. So what we generally do, this is called the standard form. It's the least known form, honestly, of a line. If you've never learned this thing, you do want to listen to this part right here. Basically, to graph a standard form, what you do is step number 1, you take the x value and you turn it into 0, and then you solve for the y value. Okay, so 0, comma y. Or, in other words, you're trying to find the y-intercept. You're trying to find the y-intercept. So let's go ahead and try that over here. You have 2 times 0 plus 3 times y is equal to 9. And you'll notice that 2 times 0 is simply 0. So you have an equation to solve. 3y is equal to 9. Therefore, y is equal to 3. So what we're trying to say here is this line is going through the point 0, comma 3. Okay? Step number 2, go back to the equation and this time find the x-intercept. All right, find the x-intercept. Now, in finding the x-intercept, what do you do now? You basically go back to the equation and you turn the y into a 0. All right, so there you go. I turned the y into a 0. And again, you solve this equation. You have the equation 2x is equal to 9. That is going to give you the answer 9 over 2, or some may say 4.5. So now we know what the x value is. So the x value is 4.5 comma 0. All right, sorry, I'm in a bit of a rush here, so I'm just making all kinds of silly mistakes. I apologize. So 4.5 comma 0. And notice that you have still managed to get 2 points for your line. And with those 2 points, what can you find? You can find the slope, right? So it can still be done. It's just not a very, commonly known form of a line. All right, thanks for listening, and Assalamu alaikum.